In this video, I'm going to go over this organic chemistry problem where we're going to predict the product and draw the mechanism here. So we see here that in the reactant molecule, we have a carboxylic acid, and on the reagents, we have an alcohol in acidic conditions. And when you have these three ingredients, a carboxylic acid, alcohol, and acidic conditions, then that is a big sign of Fischer esterification. So to predict the product quickly here, we could think of this OH of the carboxylic acid as the leaving group, and then we're going to substitute that leaving group with this nucleophile like this. Where if I were to highlight this part of the nucleophile, that's going to be this part of the products right here. And this OH right here is going to leave in the form of water, H2O. And we're going to see that through the mechanism right here. Right, so because we're in acidic conditions, the carbonyl oxygen is going to get protonated by the strong acidic conditions, H2SO4, to get this protonated carbonyl here. This would activate this carbonyl carbon and make it more electrophilic because this is a more angry, positively charged oxygen. So that would allow for this weak nucleophile alcohol to attack the carbonyl carbon, push the double bond into the oxygen, and get this tetrahedral intermediate right here. Right, now once we get this tetrahedral intermediate, this is where the proton transfer steps happen, where we're going to deprotonate the group that we want to keep, which is going to be the new group, to make that into a bad leaving group, and then we're going to protonate the group that we want to kick out, which is the old group, to kick it out. Right, so we could use the HSO4 minus that we formed in the first step to deprotonate that new group that we just added on to get this intermediate here. Now, once we have that, we're now going to protonate the OH using the H2SO4 to get this good leaving group here. Now, once we have that good leaving group, we could use the OH to reform the carbonyl and kick out that OH leaving group, which is going to give us this water side product right there and give us this last intermediate right here. Where the very last step is to deprotonate the carbonyl oxygen and make it neutral using the HSO4 minus to then give us our final product here, which is this ester right here. And we formed an ester from a carboxylic acid. And this can only be done in acidic conditions because if we were in basic conditions, that would